Okay. Part A. T of u, or T applied to u, that is just A times u. Okay, the definition was given in the question, which is 1, -1, 0, 2, 0, 3, times the vector u, 1, 0, 2, which is, excuse me, which is 1, 2, plus 0 times something. I'm going to just drop that term. 2 times 0, 3, which is 1 plus 0, and then 2 plus 6, which is 7. Okay. For b, we're solving tx is equal to b. So that's the same as a times x is equal to b, which, as we have seen, is the same as solving this system. A augmented with b. So what is that? 1, -1, 0, 2, 0, 3, oops, augmented with b, -2, -1. So we just reduce this. So let's start over here. To find this x is the same thing as solving this system, which I go ahead and do. So I'm going to do R2 minus 2 row 1. Yeah. And then you get two, 3 over 2. So I went half times row 2. Excuse me. 0, 1, 3, 2, 3, 2, blah, 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 1, 0. I'm adding, I'm going row 1 plus row 2, add 3 over 2, and minus a half. I'm going to pause and copy all that down. Okay, so what does it say? It says that x plus 3 over 2 z is -1/2. Y plus 3 over 2 z is equal to 3/2. Z is free. In the question, we are asked to find just any old x. Vector x. Okay, vector x. Sorry, I'm getting confusing here. This is the vector x, which I'm looking for, is x, y, z. So the question asks me to find just one of these. So I will take one of the infinity of solutions I found here. So I'll take z is equal to something convenient. I'll say z is equal to 2. We'll do nicely. So x plus 3 is equal to -1/2. Y plus 3 is equal to 3/2. z is equal to 2. So we get x is equal to minus 7 over 2. Y is equal to minus 1 over 2. Z is equal to 2. So the vector x is okay, I did that quickly. It's maybe a mistake, but what I want you to grasp here is, so maybe just copy that down before I start blabbering. Pause if necessary. What I want you to grasp is that to answer this question, okay, to find an x that passes this test, I'm going to solve this system and just choose one of the solutions. So I found the general solution here, which gave me infinity of solutions, and I chose one of them. Worked it out, and here is the x. Is x unique? Well, no, right? No, we found an infinity of solutions in part B. Okay, I found an infinity of solutions here, right? Okay, so it's not this vector x. And there is an infinity of possibilities. D, C in the range of T. Well, let's have a look, see. So you'll recall that the range of a function is, well, in Cal 1, the range was the set of y values that you achieve with your function. So I'll translate this question. Is C equal to T of x for some x in R3? Okay, so the range of a transformation is the set of all these guys. So the range of T is the collection of all things that look like this. So I want to find out, is C one of these guys? So I'll answer this question. I'll say, well, does T of x equal C? What we saw before is that if you're looking at this equation here, it's the same as ax is equal to c, which is the same as solving this system, a augmented with c. But we saw in, let's see, I believe 1.4, theorem 4 says that there is a solution there is an x if A has a pivot for every row Okay, now, does A have a pivot for every row? Let's see. Scroll. I apologize if I'm going quickly. Pause if you need to. Here is A. Well, a row reduced version of A. Okay, here is a row reduced version of A. And we see that it does have 1, 2 pivots. It does have a pivot for every row. And that was in B. So in B, we saw that A does have a pivot for every row. Therefore, there is an X such that T of X equals C, and so C is in the range of T. That's a lot of English. Okay.